Now let's take a look at textbook page 106 and the structure question 25. Alright, it says that in this question we have a 2.90 grams of iron nitrate, right? That has been completely converted, which means that all the reactant are going to product here, right? The product here. And the firstly, what question asking about? It asks us to calculate the mass of iron 3 oxide. So similarly, let's firstly calculate the mole for the reactant that we know first, right? If we want to get the mole, we should have the molar mass. Alright, if we want to calculate the molar mass, the iron nitrate, the molar mass should be 55.8 plus 3 times, like the 3 times is like representing here, and brackets is the mass of nitrate here. So nitrogen was 14.0 plus 16.0 times 3. And then if we add it up all together, this will be 50.8 plus 3 times bracket 14 plus 48. The answer here would be 241.8 gram per mole, right? If we have the mass, we have the molar mass. So what is the formula for mole? Again, mass over molar mass, right? And this one will be 2.90 grams divided by 241.8 gram per mole. The answer here will be 0.01199. Because the answer is still in between, so I will put 4 significant figures here. But that if that is the answer, final answer, please put it at 3 significant figure. Alright, then now let's check the mole ratio here in this balance equation. So mole ratio, that is simply equals to coefficient, right? What is the coefficient in the balance chemical equation for iron 3 nitrate and iron 3 oxide? It should be the number in front of it, right? So we simply copy it down. This one is 4, this one is 2. And then we know the ratio, we know the mole. Can we calculate the mole for iron 3 oxide? Remember, always put the unknown one at the top, like the ratio at the top, and another ratio at the bottom. And now we times 0.01199, right? So it's simply this one divided by 2. The answer should be 5.997 times 10 to the power negative 3. If you don't know how to do it, similarly, if that is negative 3, then we move to the left by 3 digits, 1, 2, 3. Then the digit will be here. It will be 0.005997, right? 0.005997. Alright, let's calculate the molar mass for iron 2, Fe2O3. So it will be 55.8 times 2 plus 16.0 times 3. So if we add it all together, the answer here will be 159.6 gram per mole. If we have the mole, and we have the molar mass, can we calculate the mass? Yes, right, because if you take a look at from here, the mass is on the right. If we simply just move, right side is divide, move to the left, it will be times, right? So here will be 2.90 grams times 159, I did the wrong one. So for the mole is 0.005997 mole, and then times 159.6 gram per mole. The answer should be equals to 0.957 grams. So here it should be A1. Answer for A1. Alright, the second answer asks us to calculate the number of oxygen atoms produced in these reactions. It has the number of, Remember, if like we have a formula like that, right? It's mole, change the color first. It will be mole equals to mass over molar mass, and also equals to the number of particles divided by L, which is our 6.02 times 10 to the power 23, the Avogadro constant, right? And so that's the number of oxygen molecules. Remember, for particles, it can be either atoms, ions, or molecules, right? So here we know that the question is asking about the oxygen molecules altogether. So here we simply use, here we'll simply use O2. All right. Do we need to know the mass and molar mass now? We do not necessarily, right? Only thing we got will be mole, and it will have the L. Then we should be able to calculate the number of oxygen molecules, right? Should be equals to the mole of oxygen times L. Let's try to calculate the mole of oxygen here. So now, how about we use the mole for this one, and to calculate the mole for oxygen here. This is a little bit messy, so how about let me erase the first part if you have copy it down. Okay, keep this one, but this part I will explicitly erase it. Right, so here, let's take a look at the mole ratio first. So the mole ratio for iron nitrate and also oxygen, it should be 4:3, right? We only take a look at the coefficient here. We have 4:3, and we also know the moles of this one. Always put the unknown at the front, and then the known one at the lower part. Then it will be times 0.01199, and then press it in your calculator to derive the answer. The answer here is like 5.99 times 10 to the power -3, right? And this one will be the mole for our oxygen derived from the equation. If we have this, can we calculate the number of particles? So let me copy down the moles here. It will be 8.99 times 10 to the power -3 mole, and times L will be Avogadro constant times 6.02 times 10 to the power 23. The answer here should be 5.41 times 10 to the power 21 oxygen molecules, right? This should be the answer for question A2. And let's take a look at B part. Suggest why the iron oxide obtained is pure. Let's think about it first. If you don't know how to do it, pause here, think about it. This answer should be pretty simple. So if we take a look at the states here, I'll write the states first. So this one should be solid. This one is also solid. These two are gases, right? If the reaction is complete, and we should be able to attain only a pure like iron oxide here, right? All the gases, they will escape and goes to elsewhere. There's a reason why the iron oxide obtained is pure here. So we just write all the other products brackets will be nitrogen dioxide and oxygen. Are gas. Are gases or gas? Or how about are in gas state? Yes. Alright, then that is the end of the question 25.